Okay, so I think that I need to introduce myself. Good morning, everybody. Excited to be in BlueTech Week. I hope that you have been listening to the other panelists and keynote speakers, and I'm really thrilled to be participating in this event. My name is Thalia Kruger. I am a naval architect, currently doing a job as Senior Business Development Manager for Principal Power. So Principal Power is not a developer, but we can say a lot about how we can facilitate an integrated approach to offshore renewable energy. This is the, okay, I think that this work? Okay, so who we are? Principal Power is a California-based company, a small company and young company, but very strong in the market. We were founded in 2007 in California, and currently we do have offices in, headquarters are in San Francisco, in San Francisco area, in Emeryville. We do have offices in Portugal, have offices in Japan, in the UK, France, and Texas, where I am based from in Houston. Since June, we have an office also over there. 120 very strong, technically savvy people that are working precisely to promote floating wind. So there is a lot of backup in terms of our history and how we reached the level that we have reached. So we see ourselves as a contributor to the whole life cycle of the wind farms. So from concept studies to pre-feeds, feeds, and then ending up into operation. Through the life cycle, it means how we back up the support that we give to the companies is because we do have the experience. And the story is coming from the fact that we have visionary leaders in our company that were looking to promote floating wind, starting in California and in Oregon with unsolicited bids. But at the time, there was no the regulatory framework, there was no the policy there, so that's why the company needed to look elsewhere. And I was very glad listening to the Portugal presentation, the Portugal representative presentation about what they did. And we found the first takers in Portugal, and we do have two projects, one in Portugal that it is spinning and producing electricity, and the other one off the coast of Aberdeen. So whenever I show the videos, they ask me, is this for real? I say, yeah, that is the real thing, working, spinning out down. So I would like to frame it whenever I was given the topic. For me was how we frame it. What is the significance that my company and myself have in this whole energy basket on all the things that we are doing. So I found a very interesting report produced by Clean Technica, where it's saying that in order to achieve that 100% energy, renewable energy in the US will allow us to cope up with the commitments from COP 21 in keeping then the temperature raising for 1.5 centigrades. Those are the goals. But this is aspirational, 100% renewable energy in the US by 2050. And I just want to think about this. This is a long-term vision, yeah? What does it mean? In terms of California, since we are in California, I also found this very interesting graph that allows me to ground myself because I'm seeing everything on the lenses, from the lenses of floating wind. And for me, everything. So I am a naval architect, so I see floating as fascinating and engaging. But then this gives me the right perspective to see what is the role that we play in the energy production. And they produce Clean Technica provided this roadmap to achieve 100% by 2050 based on existing technology. So we saw it there that our contribution, floating, is about 10%. These are, of course, they are just scenarios. Now, are they realistic? How we are going to achieve those? But then I saw this graph also, which telling me that energy consumption is increasing all the time. It's not decreasing. And it's not only in the developing countries, and it's not only the US, Europe, but everywhere. Everybody needs energy. So the energy consumption has increased 79% between 2018, and it's expected to do so till 2050. And renewables are the fastest growing energy source, surpassing oil and gas to become the most used source of energy. Let's see, but we still have a lot to do. Now, going back, that was my view on the long term, 2050. We do have goals that are 2030. 2030 is just around the corner. And I just looking into what is needed to achieve these goals by 2030. And this is what it is needed for floating, yeah? You see over there that we need 2,100 wind turbines on the water, 2,100 foundations. How many vessels? How many workforce is going to be needed? How many jobs are going to be created? And then how many cables and how many port infrastructure. And I'm talking not only about floating, but also fixed, whatever is needed, yeah? And then what are the challenges? We hear about the efforts that were done by BOEME and the California Energy Commission and the Land Commission and so on. And we see that those efforts shows are all the challenges that we are going to be facing, and at the same time, all the opportunities. I consider that these are our generation, the opportunity of our generation. And what we see in here is what we have done. This is our contribution, principal power. Yeah, it was not working, the video. Yeah, it's working now. Okay, but I have very little time, so I'm gonna. This is the real video, the real installation, integration with the wind tower. And this is, if you see there, that is offshore of the coast of Aberdeen, Kincardine project. And also we do this in terms of innovation, using innovation and technology. So this is the list of all the projects that we have been participating in order to have LCOE, to lower the LCOE. So this is our solution, and this was a small contribution, as we saw, in terms of the whole picture of what is needed to have blue economy.
Thank you, Thalia. Very, very nice pictures and very interesting, discussion in perspective with all the information you gave us. Jonah, you next. Okay.
Go. Good morning. It's good to see everybody. Thank you for the introduction. And I'm going to focus my remarks today on how we are driving the floating wind revolution at Mainstream Renewable Power, and why we see floating wind as such a big part of the blue economy, not only here in the US, but around the world. But first, let me say a few words about Mainstream and our journey on this revolution. Does work. So Mainstream Renewable Power is a Dublin-based, pure-play renewable energy company with wind, solar assets across global markets, including Europe, Americas, Africa, and the Asia-Pacific regions. We are one of the most successful developers of gigawatt scale, so large-scale renewable platforms across onshore wind, offshore wind, and solar power generation, with a portfolio as of today of 29 gigawatts, including both bottom fixed and floating offshore wind projects, which you saw from Thalia. Mainstream combines its technical expertise in floating offshore wind and supply chain management with a proven project development methodology, execution track record, and global presence to scale and industrialize offshore wind in a truly sustainable way. Now, I need to explain that Mainstream is a majority-owned company by Aker Horizons, which is a developer of green energy and green industry, and itself a part of an industrial company called Aker ASA. Very complex, a lot of Aker names, but Norwegian heritage. In August of this year, we combined with our sister company, Aker Offshore Wind, another Aker name, which brought with it technical expertise in floating offshore wind technology. I should say, full disclosure, we're also the largest shareholder in Principal Power, which Thalia represents. So as part of a broader group of companies, we are able to tap into over 180 years of maritime history, including 6 decades of planning, designing, and executing complex global offshore energy projects. We are one of the leading developers of offshore wind at scale globally. We have successfully consented Hornsea 1, which is about 1.2 gigawatts, which is currently the largest operational offshore wind project and wind plant in the world. Also developed Hornsea 2, which is 1.4 gigawatts, before selling these projects and the entire zone in 2015. We see a huge opportunity in the US to leverage our early mover position in floating offshore wind to help develop a robust floating offshore wind industry here in the US and specifically California. Floating platforms are the key to unlocking vast potential of renewable energy production, available off the west coast of the US. While this technology is relatively new in the scheme of things, it is certainly not science fiction, as you saw from Thalia's video. It exists now, it's ready to be deployed here, and is a part of an industry poised to provide multi-generational careers up and down the US coastlines. So in many areas of the world, including here in California, the only way to access the renewable energy provided by offshore wind is through the use of floating wind technology. Many of you have heard this, but 80% of the world's offshore wind resources are in water depths greater than 60 meters, which requires floating platforms rather than fixed bottom, traditional fixed bottom platforms. The wind conditions are superior when you go far offshore, especially compared to their onshore or fixed bottom offshore wind, as the capacity factors, the amount of time you're actually generating energy, is significantly higher compared to the aforementioned technologies. So nearly 60% of available offshore wind resources in the US waters are in deeper than 60 meters. So on the West Coast, deep waters make floating wind the only viable offshore wind option. I'll mention another benefit of deep water wind is that it's less intrusive. When we're looking at sites over 20 miles from shore, where we can typically avoid or at least minimize conflicts with other ocean users. So floating really offers 3 main benefits. Reliability, the consistency and the strength of the winds off the West Coast make this a reliable energy source with really high capacity factors. Second, it's a complement to solar. We have a deep penetration of solar here in California. Offshore wind tends to pick up in the evenings just as solar is coming offline. And third, the reduced conflicts. The location of floating wind miles from shore leads to reduced conflicts. There's also the potential for what we call micro-siting, which is relocating the turbines within a set space to address very localized or specific concerns. Basically, the bottom line is that the business, environmental, and social case for floating wind remains quite strong, and we are quite excited about the future. So in the US, offshore wind and floating wind in particular has been in, I'll call it the crosshairs of federal targets, policies, and state initiatives recently. At the federal level, the administration, as I think Nessie pointed out in the previous panel, has a 30 gigawatt by 2030 target. That's pretty well known. Nobody can recite that one, but they have recently issued a 15 gigawatt target for floating wind by 2035. They call that the Windshot program. This includes funding for research and development specific to floating, with initiatives aimed to drive down the cost of floating wind by 70% to a target of $45 per megawatt hour by 2035, which would be competitive with virtually all renewable technologies. So there are multiple state initiatives that require, or they're requiring floating wind. includes here in California with AB 525, which Eli went through in detail. I won't go through that, but the goals of up to 5 gigawatts by 2030 and 25 gigawatts by 2045 are important. Oregon is also exploring up to 3 gigawatts of offshore wind by 2030. And even on the East Coast, Maine has created now an offshore wind roadmap, which BOEM kicked off a multi-year, year-long leasing process with the issuance of an RFI this past August. I think it's worth to mention a couple of federal policies here because I think it's quite important. I think earlier it was mentioned the IRA, and so in August of 2022, this past year, the President signed into law the Inflation Reduction Act. This law extends the investment and production tax credits for offshore wind and other renewable energy projects through 2045, so there's certainty. This measure will reduce the cost, or LCOE, by up to 30% or more and save ratepayers billions of dollars of the life of these offshore wind farms. The second one, which everybody talks about the IRA, but a year ago, almost to the day, the Infrastructure Act was signed into law. This bipartisan $1.2 trillion Infrastructure Investment and Jobs Act is another support for the offshore wind industry in the US. It allocated roughly $17 billion to the development of ports and waterways and makes important changes to the federal permitting process. All of these are tailwinds of a new industry for the US. You know, I use the words floating wind revolution in my title because we're really going beyond building a few projects or individual projects to building a new industry that will provide clean, renewable energy to millions of American homes, create a new domestic supply chain, and create not only jobs, but multi-generational careers and career prospects in areas that haven't historically had access to these types of opportunities. So all of these targets and initiatives, even what we've seen at COP26 last year, COP27 ongoing in Egypt as we speak, these are all important. But the reality is they will not fix the climate crisis. We have to. Our board in Mainstream has set ambitious targets, not just to supply clean energy, but to build planet-positive wind farms. What does that mean? The goals and direction are clear, but how we get there is something we need to find out together. We don't have all the solutions or technologies. That's largely why I'm here, is to listen and hear and come up with interesting technologies and solutions. But we need to, we will have to contribute to developing them to make sure they are ready for us when we need them. Along the way, we'll tap into every one of our values. We'll set a new standard for industry while making a meaningful contribution to our climate targets and to protecting and restoring our ecosystem. We are, as mentioned in the slide, shown in the slide, we are proud members of the First Movers Coalition. This is signaling a demand to utilize low-emission steel within our wind farms. Per unit of electricity delivered, the life cycle greenhouse gas emissions for an offshore wind farm are a fraction of that for gas or coal or many thermal power plants. Nonetheless, we are committed to minimizing our emissions in support of our net zero commitment. Our analysis points to the production of steel as the offshore wind industry's largest source of emissions. By joining the coalition, we have committed that by 2030, at least 10% of all our steel purchase will meet the low emission benchmark. With our current portfolio of projects, this has the potential to reduce greenhouse gas emissions in our supply chain by around 500,000 tons. And if you're interested in what SDGs we are supporting, it's 4, 5, 7, 8, 13, and 16, just in case you're interested. Okay. I wanted to show an example, and at Mainstream, you know, we really pride ourselves on our sustainability efforts. That's near and dear and quite high on our goals and our strategy. So we strategically embark on innovative research projects in every region which we operate. In 2020, we received a $2 million grant from the California Energy Commission. I'll thank Eli again, to explore how we can use data to create a digital twin or a virtual representation of a floating offshore wind farm to address some of the major challenges we see in the industry that can be addressed by using smarter data gathering, namely costs and an understanding of the environmental interactions of these wind farms. The solution we're researching is how to use data gathering technologies on and around the wind farms to create a digital twin of the platform. It would help us not only collect the reams of data, terabytes and petabytes and all that, that is currently available, but to contextualize it. Help us understand what it means, make it actionable for condition and integrity management during operations, as well as environmental monitoring. Better understanding of the environmental interactions of floating offshore wind projects and how to effectively mitigate interactions is really critical. We recognize that developing a successful floating offshore wind industry depends on us being able to protect the oceans we are operating in while working in peaceful coexistence with other ocean users. Finally, one more note as I wrap. Floating wind will open up huge swaths of ocean for data gathering, in a way that could unlock a level of knowledge about our ecosystem that we haven't possibly explored before, at least not consistently. We and our partners are working on a final report to the CEC at the moment. That should be released to the public early in 2023, and we're pretty excited about the results of that. So finally, on my last slide, I'll leave you with this. I presented this exact same slide 5 years ago when I first made a presentation at BlueTech, so thank you for 5 years of invites. So we started envisioning what floating wind farms could provide for the blue economy. Beyond what I've just described in terms of environmental monitoring and so forth, we could envision co-uses for aquaculture, data centers, and many other things. There are quite literally, thanks marketing team, oceans of opportunities. Okay, I'd be happy to take questions in the panel session. So with that, I'll just say thank you.
Thank you. Plenty of questions that will come. The next speaker will bring a new wave. You're going to talk about, the wave energy. So the floor is yours.
Appreciate everyone listening and talking. As mentioned, we're not a wind energy developer, we're a wave energy developer. A little bit less mature, but hoping to walk the same path and get there sooner than later. Our goal obviously is to unlock the power in the ocean. It's an enormous resource. Anybody who spends time on the beach out here can see it, but gathering it and collecting it is a challenge, and it's a challenge in the testing frame of it. Like, you have to go offshore to test, obviously, which is expensive and takes some time. I wanted to point out here as well the benefits to the wind, solar, and wave acting together. As mentioned, as we go to 100% renewables, you need several sources of energy, and you need to have intermittencies that don't overlap too immediately. So the graph on left shows that wave has pretty small variability in the day-to-day time frame, and often our seasonal variability is phase shifted a bit with wind and solar. So then you can complement by generating power during the night, and you can also complement by having your peak loads in the winter. There's an enormous wave resource. The graph is a little hard to read, it seems like, with the light, but some agencies have shown, DOE and NREL have developed that wave energy can provide up to 30% of US electricity demand, and similar global demand, about 30%. As far as CalWave specifically, our X-Wave technology, where we differentiate is by operating in the mid-water column. And why that's important: traditionally, historically, wave energy devices operate on the surface, where you have the most power, but also you have the most exposure to storm loads. And then you end up building devices that are, very oversized structurally for the power you're trying to economically sell in order to survive those storms. So then other companies look at operating on the sea floor, where there's less wave action, which also means it's more of an economic challenge. So we've resolved this by operating in the mid-water column and using the variable water depth as our analogy to pitching wind turbine blades back into the winds. So on a clear day, when there's not as much wave action, we'll be very close to the surface. On heavier days, you get higher seas. We can go to a deeper depth to reduce that efficiency and optimize the structural loads on the system and the economic output. And then during heavy storms, you can take the device out of resonance and move it all the way down, close enough to the seafloor to really reduce those structural loads on the device and make it more survivable. As mentioned, our system, is fully autonomous, operates fully submerged, but near surface, uses a lot of the same, biofouling, anti-corrosion. There's a lot of overlaps with floating offshore wind structures, and that's why I think there's a lot of collaboration to be had in these deployments. For us as CalWave, the company, we really got started in 2015 out of UC Berkeley and the Lawrence Berkeley National Laboratories. And then we really kind of kicked off during the US Wave Energy Prize, which was where US Department of Energy looked at kind of globally what's been going on in wave energy and how to kind of put their hat in the ring in a more substantial way. And they solicited invitations for people to submit designs. And it started with 92 teams. Through 18 months of down selects, they awarded 2 companies with open ocean demonstration pilot projects. So then that was kicked off around 2017, 2018. We deployed our system in 2020 here in San Diego in collaboration with UC Berkeley and UCSD and the Scripps Institution of Oceanography. Operated for 10 months in the water and just recovered it earlier this summer. So now we're looking at parallel paths being small power data as a service, similar to what you showed for kind of using the ocean for point of use, power generation, monitoring, and by having these devices out there generating power at the point of use, you can have fully persistent monitoring, AUV charging, all of these other things that are unlocked with small devices, and then also looking to scaling up and going larger scale. As said, we're a bit less mature. We're still working to get to the large multi-megawatt systems. We have a 100 kilowatt system in development planned to be tested in Oregon at the Wave Energy Test Site up there, and in parallel developing an 800 kilowatt and a 1.6 megawatt system. So this just shows a little bit of picture of our pilot system that we deployed here in San Diego. As mentioned, we put that in the water in September of 2021, operated for 10 months continuously with no maintenance interventions, kind of no unanticipated events, and 99.8% operational time. And then we recovered that system just this past July. Just shows a little bit of our smaller scale system. Like I said, looking at 1 to 5 kilowatt continuous, maybe 10 kilowatt hours of stored energy on the system, operating in a resident environment, and that can be collecting data for helping to site offshore wind, or for NOAA, or for, recharging autonomous vehicles and things like that. And we have a bit of an advantage in some spaces in that the system does operate fully submerged. So there are applications where low observability is important, and you can kind of operate, generate power, do what you need to do, connect to your power users, and then resurface when needed to upload data. As mentioned earlier, US Department of Energy has funded a 20 megawatt wave energy test site in Oregon. I was actually just there earlier this week visiting and kind of making the rounds. They've run all the conduits already for the cables. The cables have been purchased and are looking to be installed in 2024, along with all of the grid connection infrastructure. So our plan is to start bench testing our system next year and start cutting steel on that next year to be ready to go in the water in 2024 with that system, while in parallel looking for the larger scale systems. We're a smaller team. We're currently 8 full-time staff with offices in the Oakland, Berkeley area and in Houston. We have several positions open, so if anyone's interested, feel free to come talk to me. And as mentioned too, I want to end with focusing on that potential collaboration with offshore wind. I do think as far as, we've talked today about port infrastructure needs, about offshore operations, individuals and jobs. We've talked about vessels that are needed. We've talked about shoreside infrastructure for the electrical side, offshore infrastructure on cabling, So to have multiple resources in that same marine spatial plan that aren't kind of reinventing the same wheel, we think there's a lot of collaboration that can happen, and then you can make more efficient use of that infrastructure by having multiple types of generation with different variability in the timing of that generation. And then looking at, in the short term, we think the 100 kilowatt system, is relevant for small island developing nations and microgrids and those small type of communities where that's a relevant amount of power, which is doubly important in that a lot of those places are also currently dependent on imported, barged in heavy oil and diesel fuel, which is, polluting and disruptive, but also makes those communities very dependent on that next barge coming. So if we can help them integrate more sources of local energy, you can empower them to be less dependent on that imported fuel and also less polluting for the types of fossil fuels that are the heaviest polluting. And then looking forward, larger, sustainable development goals similar to kind of everyone else up here today. So whoever has a camera, we have a QR code with access to our various social media, and looking forward to the discussions later.
Thank you, Dan.
Thank you.
Very interesting, and I have plenty of questions if we have time.
Absolutely.
So the next speaker is Lydia Lostan. She is coming from the East Coast, Shell, and she will present. We're coming back to the offshore wave.
Thanks, Pierre. Actually, I'm based in San Diego, so it's actually really nice to be able to speak about what I do here in San Diego, which has all the good things that everybody talks about, with the downside, in my opinion, that there's no wind, so it's too bad. Okay, so my name is Lydia Lostan, or Lostan, so I'm French originally. I think Pierre enjoyed pronouncing it the French way. I've been in the energy industry for the last 13 years and the last 2.5 years in offshore wind. And I know I'm being a bit like my toddler, insisting on the half year, but you have to understand that everything is going at such a pace in offshore wind that every month I feel like I'm learning so much, and it really counts. So I'm gonna focus on the word integration because I think this word really talked to me. It's a word that we use a lot at Shell. I think it's gonna be a core for us to succeed in the energy transition. We're gonna have to be thinking about collaboration and integration of actors and solutions. Trying to bring two lenses to it. So I'll speak a bit about what Shell does and how offshore wind, which is the business I come from, or I should say offshore power, but all the power we're doing right now is from wind, but we're vouching for or rooting for wave as well at some point. So I'll speak about how offshore wind integrates in the broader Shell portfolio and the Shell strategy, and then I'll also speak about how we need to take this integrative approach in offshore wind specifically to deliver successful projects. So, oops, sorry. My bad.
Any problem?
I have a problem with my my own thing, so don't worry. Yes, so usually here when I say I work for Shell, people don't know who Shell is beside the gas stations. So I have to explain that Shell is not only about the gas stations, although we have a lot of them here in California. Our goal is to be net zero carbon by 2050 or sooner, and that includes our own emissions, so coming from our own exploration and also downstream assets, so producing petroleum products, but also compensating the emissions from our customers, so people who are using our products and therefore generating their own emissions. Powering Progress is the name of our strategy, and it's about how we are accelerating the transition, how we're accelerating and bringing more and cleaner products to the world, and doing what's needed to tackle climate change. So this talks a bit about how everything fits for us at Shell. We aim to be a partner in the energy transition, And we aim to do that by bringing investment, expertise, and market building opportunities, as we have for decades throughout traditional energy industries. And because we're a global business and we work across the value chain, we can leverage these technologies and this innovation to develop and deliver solutions at scale. And the way that we see offshore wind playing a role, for instance, is really that it's foundational. In order to be able to provide all these clean products to our customers, you have to have clean generation, and offshore wind is one of the way to bring this material scale generation. Just to illustrate again that our business is about finding the right, overall energy system that works and that allows the world to move to this clean world. We are investing in many different types of energy solutions, from onshore, offshore, solar, wind, also investing in startups, technology companies. So it's not just about wind, I guess. That's kind of the key message here. So I'm going to speak now about the Shell offshore power business, which is the business where I sit in Shell, and focusing specifically. So we're a global business. We have projects everywhere in the world. In the US in particular, where we have 2 joint ventures where we're working with our partners on the East Coast. One is called Mayflower Wind in Massachusetts, which is a 50% partnership with Ocean Winds. And another one called Atlantic Shores, which is a 50% partnership with the EDF Renewables. And both these projects are moving forward with contracted procurement with the state of Massachusetts and New Jersey. One more thing I wanted to mention here is that we take our 50+ years of offshore experience, engineering experience, when we're looking at those projects. And so we believe that there's a path as well to bring this experience from our offshore oil and gas traditional businesses into this new industry, and I'll speak a bit more about that in the later panel. Okay, so this I guess is the transition now to what integration means from a project perspective. So what it will require for us to work together, and what do we need to think about when we are building an offshore wind project, basically, or we want to lead to successful project outcome. And wanted to speak a bit about what happens once we have a lease. And so the previous panel was speaking about all the process to get to an auction and for lessees to be able to acquire a lease. So I'll speak a bit more about what, as a developer, we have to do once we acquire a lease, because it's just the start of the work for us. And by the way, I do want to commend the previous panelists and the work that the state and the federal government have been doing for California, because I think it's quite remarkable how you have been able to collaborate and have been able to think about a lot of these challenges that I will be talking about in a minute proactively, and which will help tremendously accelerate and get to a successful project outcome. So once we have a lease, it's kind of the beginning for us, because we have to think about a lot of different things that need to come to fruition and need to work together to make a project successful. And I'll talk about the levelized cost of energy, because this is a unit that we use to kind of figure out if there is. Oh, I have to finish? Okay. Okay, I will just focus on a few things. I'll just say that when you have to develop a lease, you have to think about what technology you're going to be using. You have to work closely with the regulatory to frame up your permits and figure out what you will need to do to get your permits. You have to think about how you interconnect to the grid, and also all the logistics. So I think there was some discussions about ports earlier, etc. So this is a critical work that needs to happen during the development. And if everything goes well and you're able to find a successful path for your project, then you would start building it. And I'll just finish by this one because we talked about economic benefits. So we have to think about all the stakeholders. It's not just about levelized cost of energy. It's also about thinking about all the stakeholders that do have to get a benefit out of this endeavor. And we believe that offshore wind actually creates a unique ecosystem, and the scale, the materiality that it represents actually allows to do great things in terms of local content, labor, and work with communities that have been traditionally undeserved as well. And I think someone in Eli was saying in the previous panel that it's about economic benefits, but we shouldn't forget about the impact. So we need to be also careful that we're not creating new impacts by creating this new industry. So thank you.
Thank you, Lydia. So we have time for a few questions, and I'm going to start immediately. So the first question to the panel will be, is there a possibility for a small and growing company to find a place in this global marine renewable energy panorama? Because the CapEx investment is huge. So can you afford, and my question is directly for you, Dan, can you afford, to be one significant player if you're not Shell?
So I would say one aspect of that is we probably spend as much time fundraising as we do building stuff, it feels like sometimes, because it is, and that's where starting small scale and reaching that maturity stepwise is important, because you can only get enough money to do X, before you've done kind of Y. Whereas I think as a larger company, you can parallelize and do more things at the same time. And we are a bit, reliant on government support, which we've gotten a lot of support from the Department of Energy, but that's also very time consuming. So it's that circular process of, it's tough to get a lot of private investment until you reach a certain amount of maturity, and it's tough to reach maturity until you get investment. So then that investment comes from the government, which we're very thankful for, but that's a very time-consuming process. So what we've found going forward is partnerships. We find folks like Aker and folks like Shell, and our core intellectual property, and I think a lot of the developers in my space are similar, is the wave energy system itself. I don't need to be an expert on anchoring and mooring and permitting, and we have to do that ourselves when we need to. So being able to keep our team as laser focused on the technology development and find the right partners to do those more complex things that they're used to and they're good at, I think is kind of where that lands.
Yeah, interesting. This afternoon we talk about the mix of the different renewable marine energy, and I think there's a great opportunity for people to collaborate, and I think that you're part of the solution. Now my next question, I'll go to the other side of panel, going back to Lydia. So as a big oil and gas company transitioning to the renewable, how do you envisage the future? Is it the direction for you that is mandatory? Are you moving into that direction because of the regulatory constraint, or is it really a very good commercial opportunity that you intend to as an issue to occupy in the future?
Okay, I'll try to answer this. So I think it's a given that we support the Paris agreements. So there's no doubt that there needs to be a transition. I think this is a given, and we're just there is no choice for anyone, and there is a strong belief that this will need to happen, and it is happening. We are transitioning our businesses towards more and more renewables. You had a question about commercial opportunities. Yes, I mean, Shell is a business, and we have to provide returns to our stakeholders. So it has to be a commercially beneficial business. I guess it has to be a business that works. Yes, and that's what we're working on. And offshore wind is definitely a scalable business in that sense.
Thalia, what would be, the ideal target for you in terms of country positioning? If you want to develop, a project, are you trying to look at the possibilities? Are you lobbying with government? How do you proceed when you want to establish a new, I would say, a new development offshore? Is it very passive and you wait that concessions are opening, or are you working long in advance and talk with the government? And I'm thinking about, small island states that are in really need, for this type of energy. How do you address, this kind of issue?
So it is a long process, I would say, and it is very thoughtful process because what we are analyzing. First, we are analyzing the wind resource. We are checking in all the areas where the wind resource is the one that we needed to develop our project, of course, and then the depth of the seafloor. Yeah. So once these two elements are in the mid-ocean conditions, the wind and the seafloor, the depth that it has to be more than 60 meters, then we are certain that we can launch floating wind. Now, the process that it is, I think that it is in each one of the companies is how do you analyze or prioritize the markets that you are in. Yeah? So there are, and this is in general, whenever you are launching this new energy in emerging markets, what are the drivers? Yeah? So you need to have the right policy enablers. You need to have the regulatory framework. And then, of course, the other elements that contribute to a successful launching of the projects. And then we go into precisely the supply chain, the workforce, the infrastructure. That is all what we need to have in, for example, in California and in general in the United States. Yeah? So we analyze all these factors, and analyzing all these factors, then we decide, okay, we are going to prioritize this market or that market. And that's how it has allowed our company to grow. And so we are looking into Japan, into Korea, for example. We do have projects actually going there. Of course, because of the opportunity of having our first pilot, and that was Portugal. And Portugal has already launched their ambitions to have 10 gigawatts in the next years. Yeah. So what we are seeing and what I am particularly excited is about all these markets that are popping. And I'm looking, for example, in South America, Colombia. Colombia has the aspirations to have to be the hydrogen hub. Now, Canada, for example, Canada is very interesting. So you see all these markets that have been kind of dormant, and now they are fully embracing the possibilities that this industry brings to all of us. I don't know if I have responded.
Yeah, partially. I will come back to this.
I'm going to add something here that I think is important. I think it's very well said, Thalia. I think the other aspect of the wind resource, the water depth, it's where it can be industrialized. And that's why you're seeing, for floating, you're seeing three main markets really come to the fore. South Korea being the first. And you're going to see multiple gigawatts before 2030, maybe 6 or 8 gigawatts before 2030. You're going to see the UK, which you see the results of Scotland, 15 gigawatts, something like that. And I think it's maybe a touch higher. We just got 1.8 gigawatts a couple months ago. And then California. Those are your three hotspots. When you talk about floating wind, those are your three prioritized markets globally. There will be others. You're going to see others pop up. Canada will pop up, East Coast, maybe the Gulf of Mexico, maybe others. But those, the top three, those are your top three.
And John, talking about your company with the history that you have, because you're coming from Norway, you have the DNA, Norwegian DNA in your infrastructure. How did you transition, from Aker, to the wind energy? What was, the vision, to move into that direction? Because Aker, is more into the aquaculture, the offshore, and the infrastructure. So what was the philosophy behind this?
Yeah, I can tell you the philosophy because I'm the one who wrote it. It is using the skills we had and we currently have, the competencies, the core competencies of the group, And keep in mind, the Aker group is 40,000 people. It's not quite as big as Shell, but it's it's in there. Using the offshore expertise, being able to build big, floating things. We have had experience of something like 60% of what's floating in the ocean today. We've had a hand in, either designing it or constructing it or deploying it, as well as all of the, we'll call the BOP, the balance of plant around a floating offshore wind farm. We've got all those too. So using those competencies and seeing a market that was developing, now this is going on 6 years ago, we couldn't be happier. Look what we've done. We've launched Aker Horizons, which is the parent company of Mainstream, 2 years ago, July of 2020. We launched Aker Offshore Wind and then took a stake in Mainstream and now have combined them. So this is a journey that we're on. Mainstream is now over 700 people focused on offshore wind and onshore wind and solar. That's pretty exciting within a larger, 40,000 plus person organization. So exciting times, and we'll continue to, cause trouble. Yeah.
Thank you. The next question is about, the next commercial step. Hydrogen is very hype, and I know that Shell, has been, initiating, some very good step, into that direction. What we call the blue hydrogen, the true blue hydrogen, is the one that we're going to produce, cracking the H2, from the ocean. So do you think that the wind energy is a key driver, for accessing this future cheap hydrogen, or is it one very dreamy situation? Lydia, you want to start first?
Yes, I'll give it a try. Yes, I think we're definitely looking at, hydrogen, so power to hydrogen, power to other type of products. I think if it's offshore wind or another type of generation, it will depend on this levelized cost of energy. We have to use the right source of energy that makes sense for creating the hydrogen product that also makes sense and is affordable. So I think for us it will be more of a case by case per market. Does it make sense to have an offshore wind to hydrogen type of business case or not? And so it mostly depends on the cost of generating that offshore wind power.
I will just add, we're maybe a little biased towards green hydrogen because we like electrolyzers. That's just our preference. But that being said, I think on top of what Lydia said, the levelized cost of energy is what the Inflation Reduction Act has brought to the table for the U.S. You're seeing, I'm sure many of you have been paying attention to what's going on at COP27. That is the talk of the town right now, is the IRA, and how that will kind of change the game when we talk about green hydrogen production in the U.S. I think up until the IRA being passed, you could argue it was a European market. That has changed. So I think there's a lot, whether it's offshore, whether it's onshore, it's all about the input cost.
And for us, it's the right combination, yeah. Especially whenever you don't have means you don't want to worry about transmission lines, and then you can actually have, and we do have a pilot project, which is a concept that already have been sanctioned to be built, the pilot, which is called the Dolphin, DOLPHIN. You can check it out. And the reports of that concept study are public, and that was with a UK company, ERM, in Scotland. And then you can see that is how we are going to be doing this hydrogen, blue hydrogen revolution or production. And whenever you have the right combination of wind farm with the right real estate where you can install all the equipment that it's needed, all the equipment for the electrolysis and so on, then you can have a good combination of that.
Yeah, so I think we've only looked at hydrogen a little bit. We're still kind of developing our own stuff. I have seen pilot projects, like when I was working in Scotland, where My understanding is the transportation of it is the tricky part. So if you can do point of use sources, like I think in the islands up there, they over-generate wind, and then they have the city buses and they have the ferries and things on hydrogen, and it's, you know, much more cost-effective in that environment, and then sorting out the transportation aspects.
Thank you very much. So I guess, we don't have time for questions, and because we're going to break here for lunch. We're going to come back, talking about workforce and a new perspective. I'd like you, to join me, thank all our panelists. And they will be around, for questions during the lunch, and don't hesitate to reach out, because I'm pretty sure that they're looking for partnership. I mentioned, the people working, in the environmentals. This is a good time, for you to join them, and talk and present your solutions. Thank you.